Okay, good morning, everyone.
Good morning, sir.
Good morning, sir.
Good
Good
morning,
morning,
sir.
sir.
Good morning, sir.
So yesterday we were looking at the types of events. We have already uh, completed the basic requirements for our probability. Those are the experiment, then the type of sample spaces. After the type of sample spaces, we have seen the types of events, and we were solving the examples, looking at the events. So one example we have solved. I said that we'll solve one or two more examples as per requirement. So the next question is, write down sample space for the following. In the following experiments, also state the type. Also state the type. In the first one, examination results are noted for 3 students. Are noted for 3 students. Yes. What will be the sample space? Be quick. It is not so difficult. Okay, at least tell me the type of sample space, which type of sample space this is going to be. Yes, man, finite. So that will be, how can we note that? All three are pass, two are pass, one is fail, second is fail, other two pass, right? Then two are fail, one is pass, all three are fail. Clear? Sample spaces is finite. Hence discrete. Second example, 10 radio sets are checked. and number of defective sets are noted, and number of defective sets are noted.
Sir, Ritika Oza is in the waiting room.
Yes. So what will be the sample space now? How many defectives can be there? What is the possibility? Tell me.
Maximum 10.
Can there be no defective?
Yes. No,
No, there has to be some defective.
sir, because here we have question in which we have 10 radio sets are checked and a number of defective sets are noted. So there is something that that is why we are noting it down.
Okay.
There needs to
It
be some defective set.
needs to be some defective. Is there a echo in my voice?
No, sir.
No. Fine. Fine. So there may be 0 defectives, or there can be 1 defective, 2 defectives. The possibility is 10 defectives. Again, the same, finite, hence discrete. Third, items coming off a production line. Are marked defective. Capital D, or non-defective. Capital N. This is continued. This is continued till 2 consecutive and defectives are produced. Or 4 items have been checked, or 4 items have been checked. Whichever occurs first. Yes. Who's going to try this? Let me just scroll down a bit. Yes. Ved. Akanksha. No one, you cannot write sample space. How will you find probability?
Sir,
Huh,
I'm not sure, but it could be NN
just
or
a
the
minute.
first one.
NN.
Yes, NN, and then the production line will stop. Or DNN.
No. Read the question correctly. You're understanding it, but you're not writing it correctly. Items coming off a production line are marked defective D, non-defective N. This is continued till two consecutive defectives are produced.
Oh,
Defective के
sorry,
लिए क्या है?
DD then. The first one should
हाँ,
be DD.
हाँ, that's what I said. You're
I,
understanding,
I
but
messed
not
that up.
DD,
Then NDD,
NDD.
uh, DND,
Uh,
DNDN or DNDD or something like that. Any
D,
possibilities?
N, DD,
Then uh,
N,
DDNN,
NNDD,
BDN,
NDND, D, DNDD is there, NNDD is there,
DDNN,
NDND there, DNDN, NDNN, NNN, D, DNNN, NN, oh sorry, NN, DN, and the last one. So once we get non-defective 4 items consecutively, we'll stop. DDNN cannot be there. The reason is Manas,
the first two are defective, so the line will stop.
the line will stop. So that cannot be there. Okay. So the sample space is again discrete and finite. Discrete and finite. The fourth one, a coin is tossed until head appears. Coin is tossed until head appears. for the first time? Yes, Yashodan.
Right, would be
No,
infinite.
wait, Manas, wait.
Sir,
Uh-huh.
sir, it will be countably infinite.
Uh, I want the sample space. Chris, can you tell me? Wait, Aditya. I told you I have to give the marks. If I don't identify, it'll be very difficult for me later. Yes, Ishika. Janvi. Latasha. Param Mayur. Raj Vaidya. Shivam Acharya. Suhab. Sumit.
Sir,
Uh-huh.
am I audible?
Yes, wait, Saurav. Let me just check the actives and inactives.
No, sir, not about fourth. I was asking you, but unfortunately, net went away. I wanted to ask about that, how that DD and NDD came in the third example.
Yes, wait a minute. Wait a minute.
Okay.
Yash Bhatia.
So can I say?
No, wait.
So can you repeat the question?
I want the sample space when a coin is tossed until head appears for the first time.
So the sample space will be head, then so tail head, then tail head, then tail head until infinity.
Okay, so the type of sample spaces.
Infine. So head, then tail head up till infinity.
Infinity.
What is the type of sample space here?
Continuous sample space.
Continuous, okay.
Yes, sir. Continuous.
Dromel, okay. Akanksha, what is the sample space here?
Sir,
Type of
HHT
So
will not
it's
come.
infinite.
infinite. Discrete or continuous?
Continuous.
Continuous.
Okay.
Sir, HHT will not come.
You tell me, will it come?
No, it's the first time. Yeah. No, will not come. Not come.
Okay. Dhruv, Bafna, which type of sample space is this?
So continuous infinite.
Okay, continuous infinite.
Sir,
Hmm.
can
Yes,
I
sir.
now ask the third one because I got disconnected? Can you just tell me how DD and NDD came? That's
Beta, wait, my dear Saurav, please wait.
Sir,
I'll clear your difficulty. Yes, Ishika.
so won't this be discrete, countably infinite one?
Where were you when I was asking you, Ishika?
Sir, actually, I was just thinking about the answer.
This is discrete.
Countably infinite.
Countably infinite.
Countable.
Countably infinite. Okay. Fifth one. Yes, Saurav, are you there?
Yes, sir. Here only.
So the question is that your items are coming off a production line, and each product is marked defective or non-defective. The defective is marked as D and non-defective as capital N. So this is continued until two defectives are produced. Okay, either I will get two defectives or I will get four items non-defective. Until then, you are going to do this. The process is going to be, so item comes, I'll mark it N or I'll mark it D. And if I get two defectives, the product will, the checking will stop. Or if I get four products non-defective. So the first possibility, I'll directly get two defectives and I'll stop there, or I'll get one non-defective, two defectives, and then the process will stop. Or I'll get first defective, second not defective. So I cannot stop there and I'll get two defectives. So here I'll stop, and this is how all the four possibilities are given. Is it clear now?
Yes, means it was two consecutive defectives. That's why we started from DD, then
Yes,
NDD.
yes.
Okay.
Life of an electric bulb. Life of an electric bulb. Produced by a company. Yes. Where is Sakshi today?
So that is it.
Yes. Ritisha, what will be the sample space in this case? Ritika,
Yes, sir. Uh,
yes. Sample space in this case. Samrad,
Sir, sir, it can be 0 to any finite number.
yes, 0 to infinite.
So 0 will not come, na?
Why?
So because the
Can
bulb
blow
will
off
glow
immediately.
when there
Bulb
when
is defective.
It will not glow.
Hmm.
but it's
Bulb
not
is,
given in question, na, sir, that it is defective or not.
but life is measured. Life is 0 for defective.
Okay.
So what is the type? Type of this Drumel?
So continuous.
Continuous. Uncountably infinite. Continuous. Countably infinite. Uncountably infinite. Fine. Just mute yourself. The next example is a committee of 3 persons is to be formed. Is to be formed from 5 persons. A, B, C, D, and E. First one, write down appropriate sample space. B, write down the events. Okay. Write down the events. Where even is A is not selected. A is not selected. E2 is B and C both are selected. E3 B and C selected but not D. Yes.
So here we need to use the combinations.
Yeah.
Okay.
You can determine the number by combinations, but when it is about the actual sample space, your combinations, I mean the NCR won't work.
Yes,
NCR will give you the total number of elements in your sample space.
Okay, sir.
How many elements are going to be there? Anyone? Anyhow, we will need the combinations.
60.
So 5, C, 3. So out of 5, you're
10.
choosing 3, right? So 5 factorial, 3 factorial, 5 minus 3 factorial. How many it is?
Sir, it should be
10.
5 3.
10.
How you got 60? NPR, I guess you took.
Yes.
So it's not permutation. Look, there is a basic definition. We'll need this later again. So I'll just introduce you right now. So when you want to choose, okay, so you have certain possibilities, and out of that you need to choose. In that case, we'll take the combinations. When you need different types of arrangements, then we'll take the permutation. Okay, so you have a mobile number, whatever your mobile number is, and whatever digits are there, you need to arrange it in different manner. Then what will you use is the permutation. If there is an arrangement, okay, so then we'll choose an permutation. And when there is a choosing, so out of 10, you need to choose 3 or 4 different numbers or digits.
Like
Then
selection.
we'll use the combinations. Fine. So let's write down the sample space. So we need 10 elements, okay? Remember that. ABC, then A, B, D. So I'll write it down in this manner: A, B, C, D, E. So A, B, C, A, B, D, then A, B, E, then A, C, D, then A, C, E, then A, D, E, then B, C, D, then B, C, E, then C, D, E. Fine. I think that's enough. 1, 2, 3, 4, 5, 6, 7, 8, 9. Still one is missing.
BDE, sir, BDE.
B, D, E. Fine. So I hope you have understood. I was just going by this A, B, C, then A, B, D, A, B, E, and so on. Fine. Now let's just write down the events E1, E2, and E3. So E1 is A is not selected. So there are 4: B, C, D, B, C, E, C, D, E, and B, D, E. Then E2, B and C both are selected. So B and C both are selected. This one, this. So there are 3 elements: A, B, C, B, C, D, B, C, E. E3, B and C selected but not D. That is A, B, C, and
BCE.
B, C, E. That's so that is all about our first chapter, which is first point in the probability, the sample space. Now we'll start with the new one, which is probability. So what is probability? Someone said in the previous lecture that it is the number of elements belonging to A, belonging to certain event, upon total number of elements in the sample space.
Sir,
Huh.
the formula wise, we can say that P of A is equal to N of A upon N of S, where N of S is the total events.
Yes.
So number of favorable outcomes upon number of total outcomes.
Yes. So before we start with the probability, we'll see what is equiprobable sample space. Equiprobable sample space. So say your cricket team is playing a match with the Indian cricket team, and there are going to be 10 matches, and after 10 matches, and I'm recording everything for the 10 matches. So what is the possibility that who is going to win? So in this case, if the cricket team of say MIT WPU is having a match with Indian cricket team, so the possibility is that almost all the matches the Indian cricket team is going to win. So sample space, when I create a sample space, so it may happen that the MIT WPU team will win no matches. There's a possibility that they may win one match or two match or three match or all the 10 matches. The sample space is going to be the same. Okay, so but what is the probability of sample spaces for the win of MIT WPU and the other? Say I'll just consider the 5 matches. So win, lose, 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 lose. There can be 2 wins, lose, lose, lose. 3 wins, lose, lose. 4 wins, lose. All the 5 wins, or all the 5 lose. Okay, this is the sample space. I hope the sample space is clear to you now. But what is the probability? Whose probability is the highest of these all sample points?
All losses.
Sir, all
All
losses.
losses. All losses is having the highest probability. I mean, you can even consider this the occurrence of this sample point is say 90%. Okay, so the problem is in this type of experiment, each of the sample point does not have equal probability of occurring. Okay, but when I toss a coin, a fair coin, the probability of getting a head is equal to the probability of getting a tail. Okay, so this is the meaning of equiprobable sample space. So equiprobable sample space is the sample space in which each of the sample point is having equal probability of occurrence. Okay, so this type of sample space are called the equiprobable sample space. A random experiment, random experiment which has n mutually exclusive outcomes, which has n mutually exclusive outcome. The sample space, sigma is said to be equiprobable is said to be equiprobable if all outcomes are equally likely. Okay, so I'll simply write down, say, if my sample space is equal to omega 1, omega 2, and I have up to omega n. And I'm saying that this is equiprobable sample space. Equiprobable. Then probability of any omega I is equal to, shall say, omega 1 is equal to probability of omega 2 is equal to probability of omega n is equal to. Yes, what will be the probability? The total probability is always
1.
1.
1.
So probability of each of this is going to be 1 by n, because 1 you are dividing it into how many equal parts? N equal parts, right? So 1 is the total probability and there are n elements. So each must have equal probability of occurrence. So 1 by n is the probability of each and every one. So once we have defined this, I'll write down the definition for a probability of an event. Probability of an event. If a random experiment, if a random experiment results in n mutually exclusive equally likely outcomes, out of which m are favorable, m are favorable to the event A. Then probability of occurrence of event A is denoted by P of A. And is defined as yes, P of A is equal to
M by n.
m by n. What is the relation between m and n? M is lesser than n. Why?
The fraction cannot be greater than 1. This max value.
Cannot be greater than 1, but it has no relation between this concrete relation between m and n. Why m is less? What is m? M is the outcomes are favorable to A. And what is A? A is an event. Event will always have always a subset of the sample space. So an event must always have less number of elements than what is in sample space. Fine. Remark. One. 0 is less than or equal to P of A is less than or equal to 1. So probability of an event always lies between 0 and 1. No, only real. Fine. Example. If a pair of unbiased coin is tossed, obtain the probability of of the occurrence of 1. Both heads second, single head third, at least one head. Yes, let's go one by one again. That is sample space. Yes, Saurav, what is sample space?
Sir, first it will be HH,
Hmm.
then HT,
HT,
TH,
TH,
TT.
TT. Okay, thank you.
It will be 4.
Yeah. Drumel, Drumel, gone. Yes, Hasnan.
Yes, sir.
Yes, the first event is both heads. So I'll name it A. What are the possibilities?
Sir, H and pair of coins. So HT, HT, and
I want
TH.
the sample points. Those are favorable to event A.
Yes, sir.
So
HH
Only HH will.
and
Okay.
HT and TH.
HT and TH. Okay, thank you.
Sir, but this will not consider. We will not consider HH because here we have written. Here we have single head. This case will be considered in the third case. This is the third case actually.
A is actually this one, the first one. I was asking you about the first one, both heads.
Okay, okay. Sir.
So
So
what are
Only
the
one will
possible?
come.
So
Only
only
one.
one.
Sir, only HH.
Only HH will come.
The B event, single head,
HT and TH.
HT and TH. Okay. And the third one C is
Whatever what I said first time. HH, HT, and
HH,
TH.
HT, and TH.
HS, HT, TH. So probability of A. How many
1 by
elements?
4.
1
1 by
by
4.
4.
1 by 2.
This is 1 by 2.
And last is 3 by 4.
3 by 4.
C is equal to 3 by 4. Okay, before I conclude the lecture, let me just make it clear. This formula that you are using for the probability is for equiprobable sample space only. Remember that. Whenever your sample space is not equiprobable, you cannot use this formula. Okay, because in the definition itself, what we have written, in the definition itself, what we have written, so I'll go to the definition of probability. N mutually exclusive equally likely outcomes. Because equally likely outcome means that your sample space needs to be equiprobable. Okay, then and then only you can use this definition, otherwise you cannot. But anyway, in our syllabus we only look at this equiprobable sample space. Fine, that's all from my side. If there is any difficulty, you can ask.